All right. My project title has been changed a little bit. Now it's Thermo Fluid Transport Phenomena in Membrane Desalination. I am Mengesha, sophomore mechanical engineering major here at UDC, and my project mentor is Dr. Mohammed Reza Shahiri. Here is the outline for this presentation. I will jump to the motivation. 71% of Earth's surface is covered with water. However, 96.5 of it is covered with ocean water, which is saline that we cannot use directly. And as WHO reported, 1 in 3 people are without the access of drinking water right now, and this problem is gonna get worse in the future. So it's necessary to develop an effective desalination technology to resolve this problem. And membrane desalination (MD) has been identified as one of the most effective desalination techniques. And among different types of membrane desalination, direct contact membrane desalination (DCMD) show higher permaflux and good suitability. So that's why I want to work with DCMD. The first literature review is by can I hide this thing? Oh, whatever. By Ashur et al. It is titled with Principal Application of Direct Contact Membrane Distillation (DCMD). It's a comprehensive review that I give most of the basics about direct contact membrane desalination and MD. MD is a thermally driven membrane separation process where only the water vapor molecule in a hot feed can move through the pores of the hydrophobic membrane. We can use it for the treatment of produced water, groundwater purification, removal of micropollutants from drinking water, concentration of juice, and other applications. Incorporation of renewable energy with DCMD shows to improve efficiency of DCMD while reducing fossil fuel technology. Second literature review is by He, and they review the ceramic-based membrane for water and wastewater treatment, considering their material property, efficiency, application, and manufacturing. They stated that polymer membranes are currently the most kind of membrane used in wastewater treatment and desalination, but they have some limitation in their use, such as poor long-term stability, easily falling. In the other hand, ceramic membrane have different advantages like longer stability, lower falling rate, despite the constant pressure to lower the production cost. The third literature review is by McFandy et al. Thin film deposition techniques for polymer membranes. They review variety of thin film deposition process to increase reliability and efficiency around water treatment system and their application for modification of polymer membranes. They discuss different kinds of deposition techniques such as sputtering, thermal evaporation, chemical evaporation deposition, atomic layer deposition, electrochemical deposition, and others. They include their relative advantage of each coating process. They stated that PVD techniques are commonly beneficial due to their low cost, ease of use, and scalability. E-beam evaporation is more flexible than thermal evaporation. ALD is effective at changing the surface property of porous polymer membrane, and it's also useful for balancing membrane permeability and selectivity. Here we got the research question. The first question is how we can assay heat and mass transfer in DCMD. Second, we have what are the material used in for the membrane and what's their advantage and disadvantage. Third, how we can improve this advantage that we see in the question too. Heat and mass transfer. Heat and mass transfer through DCMD while the water vapor passed through the pores of the membrane. Heat transfer in three regions. The first region is when the heat transfer from the feed side to the feed membrane interference to the feed terminal boundary from this side of the feed to the membrane. This is the membrane. So we got the first heat transfer right here. And the second is the heat transfer from the feed membrane interference to the membrane permeate interference, which means from this side of the membrane to this side of the membrane. And third, the heat transfer from the membrane permeate side interference to the permeate side. So the last one is going to be from this side of the membrane to the cold permeate side. Heat transfer is the same as, mass transfer is the same as heat transfer, and we can find it using this correlation right here. And equations are adopted from Ashur et al. Membrane materials. It's essential for a membrane material to be suitable for the process to achieve an effective and long-term desalination using MD. So for a material to be suitable, it has to follow some important properties, such as it has to be hydrophobic, it has to be small as possible, it has to have a lower porosity factor, high porosity, high level of thermal efficiency. It has to be permeable and selective. Here are the example of commonly used polymers and ceramics. Next, we have the comparison between polymers and ceramics as a material for the membrane. We can see their advantage and disadvantage in here. First, we have polymers. Polymers have advantage of being cheaper, easily modified, and hydrophobic. However, they have low chemical and thermal stability. They are hard to clean. They have a high falling rate, low chemical strength, low LEP, low permeability, and high chemical and thermal conductivity. This make us look for ceramics over them. Ceramics have almost all the needed property without the hydrophobicity, because ceramics are hydrophilic in nature due to the presence of hydroxyl group attached to them. Other than that, they have a high thermal and chemical stability, high chemical strength, and high tolerance to harsh condition, and all the advantages that we see in here makes them perfect for DCMD. Surface modification for ceramic membrane. Now we know that ceramics are our materials to work with. As I mentioned earlier, ceramics are hydrophilic in nature, so they need surface modification to change them to hydrophobic, so we can use them as a membrane. And surface deposition methods such as thin film deposition may be used to deal with this problem. And there are a variety of thin film deposition processes. Here we have some of the examples of thin film deposition. Techniques of thin film deposition. Here I choose 3 subtypes of the main type of thin film deposition that we see earlier, to examine the advantage and drawbacks of them being used for ceramic deposition for the technique of DCMD. But for the time being, I'm not gonna go all through all of them, but the main thing to note in here is that ALED has the most advantages and low drawbacks. So that's our thin film deposition to go with. Now we know that ALD is a base technique, so what's ALD and how it works? ALD is a vapor deposition technique capable of producing a very thin film of a variety material. It happens when a chemical components are added to the surface and chemically react to the surface in atomic scale to form a submonolayer of thin film. ALD is a cycle process. Each step of this phase creates one monolayer, and by repeating it, the thickness of the deposition can be accurately controlled. The membrane pores will have even layer by using ALD, since it allows covering the inside of the membrane pores without significantly affecting the pore size. In conclusion, we can say that MED is a promising technology that has the potential to help us to solve the problem of water scarcity, and DCMD is the simplest and suitable configuration. Heat and mass transfer simultaneously when the water vapor passes through the pores of the membrane. The membrane of DCMD should have a certain behavior such as hydrophobic, thin, and efficient. Polymer membranes are good for their hydrophobic sake, but they have a higher falling rate and other drawbacks. Ceramics need surface modification to be used as a membrane for desalination. After that, they will meet the necessary property of the membrane. ALD is the best thin film deposition to modify the ceramic membranes. In the future, we planning to work on developing high performance ceramic membrane for desalination. I wrote a mini grant proposal to work on this project, of course, with my mentor help, Dr. Shahiri, and knowledge that I get from material science course. Acknowledgement. I would like to acknowledge the University of District of Columbia for providing this opportunity. Lockheed Martin is a fellowship program for providing the fund and support this project. And I'm really grateful to my mentor, Dr. Mohammed Riza Shahiri, for his encouragement and help throughout this project. Thank you for listening. If you have any question, I will take them now.
Are there any questions? I could maybe pose one, and that is, can you go back, I think, 2 slides?
Okay.
No, one further, no, further forward.
In the conclusion, or?
Yeah, in the conclusion, so that when you said ALD was selected as the best method for modifying ceramic membranes, and then the following slide in future work. Yes, so what do you see in an ideal world where you could do whatever you wanted with ALD? How are you going to modify the ceramic membrane to make it better for desalination?
Ceramic membranes will be like super hydrophobic. Like you can make them hydrophobic and then super hydrophobic.
Okay, so that's what you'd use ALD for?
Yeah.
On the ceramic membranes?
Uh-huh.
Okay, understood. Okay, thank you.
You're welcome.
Okay, and then
You have answered question?
no, that's it. No, thank you.